Hello guys, this is Rachna Twinkle. So far I have explained you the classification of the organic compounds, IPC rules and the nomenclature of alkanes, alkenes and alkynes. In this lesson I'll explain you the nomenclature of aldehydes and ketones. So before starting the nomenclature of aldehydes and ketones, I will revise you the previous concepts. For alkanes, the suffix is given by ane. And for alkenes, that is for the double bonded carbon chains, the suffix is given by ene. And for alkynes, that is for the triple bonded carbon chains, the suffix is given by yne. Alkenes are saturated hydrocarbons and alkenes and alkynes are unsaturated hydrocarbons. Now let's see how to name ketones. Ketones are given by the suffix oxo, on and prefix on. The prefix for ketones is oxo and for suffix it is one. The general formula for ketones is CnH2nO. For the carbonyl group, if two alkyl groups are attached, then they are called as ketones. These alkyl groups may be same or different. Now let's see how to name ketones. So first is to number the parent chain. Identify the parent chain and number the parent chain so that the ketone gets the lower value. Here we have 4 carbons. That means just the way we write alkenes, if we have 4 carbons, we write it as butane. So here we write it as butane and we drop the E and write the suffix ONE. So here we have 4, so it becomes butane. We drop E and we write it as 2-one. So this becomes butane 2-one. So this is how we write. This is also called as, we can even write like this, ethyl methyl ketone. This is also called as ethyl methyl ketone. So this is a parent chain. We number the parent chain. This is how we number it. Now here we have 2 substituents. So write it as 2,4 dimethyl. We have 5 carbons, so it is pentane and 3-one. Here 3 carbons, so it is propanone, and the common name for this is acetone. Here we have a cyclocompound, cycloketone. So we start numbering in such a way that the ketone gets the lower values. So we start numbering it from here. So this becomes, and we have a substitute here, so this becomes 3-methyl. We have a 3-methyl group on the 3rd carbon, so it becomes 3-methyl and prefix cyclo is given, cyclopentane 1-one or pentanone. Here we have a ketone and a double bond. According to the preferences, ketones have higher preferences than double bond. So we have to number in such a way that the ketone gets the lower value. So if we number this way, the double bond is on the 2nd carbon. If we number this way, then the double bond gets the higher value. So we have to make sure that the ketone and the double bond gets the lower values. So this becomes 5,6 dimethyl. We have 6 here, so hex. The root word is hex, and on the 2nd carbon we have double bond. So the suffix is given as ene, and for ketone the suffix is one. And finally the name of the compound becomes 5,6 dimethyl hex 2-en. We drop the E and write 1-one. Here we have an alcohol group and a ketone. According to the preferences, ketone is preferred. First is ketone and next is alcohol. So this is how we number it. And this is treated as the principal functional group, and this as the substituent. The substituents are written front, that is they are given by the prefixes. For alcohol group, the prefix is hydroxy. So it's on the 4th carbon, so we write it as 4-hydroxy, 4-methyl. We have 5 carbons, so it is pentane 2-one. Here we have a carboxylic acid and a ketone. According to the preference order, carboxylic acid is preferred than ketone. First is carboxylic acid. So this is the principal functional group, and other functional groups are written as prefixes. So this becomes, this is how we number it. 3-oxo, the prefix for ketone is oxo. So write it as 3-oxo-butene, and the suffix for the carboxylic acid is oic acid. So this becomes 3-oxo-butanoic acid. And here this is the main chain because we have a ketone group, so this becomes the main chain. And here we have a double bond and a cyclohexyl. So if you number this way, we are getting it 3, and if you number this way also we are getting it 3. So now we have to make sure that the double bond gets the lower values. So we start numbering it this way. This becomes 1-cyclohexyl pent 1. On the first carbon we have double bond, so it is 1En 3-on. 3-on. Now let's see how to name aldehydes. Aldehydes are given by the prefix formyl and suffix al. The carbonyl group is attached to one alkyl group and a hydrogen atom. There is an exception. Here the methanol has 2 hydrogen atoms. The carbonyl group is attached to 2 hydrogen atoms. Now let's see how to name aldehydes. Here we have 2 carbons. So the root word is eth, just the way we write alkanes. If you have 2, we write it as ethane. We drop e here and add the suffix al. Because it is an aldehyde, we write it as ethan al. So this becomes ethanol, and the common name is acetaldehyde. And here we have 1 carbon, so this becomes methanol. We have an aldehyde group, so it becomes methanol, and the common name is formaldehyde. Here we have 3 carbons, and this is an aldehyde group, so this becomes propan al, or propan 1al, or propanol. We have to number in such a way that the aldehyde groups get the lower value. Here we have a alcohol group and aldehyde group. So according to the preferences, aldehydes are preferred first and then alcohols. So this is treated as a substituent. So we write it as 3-hydroxy. We have 4, so 4 carbons, so we write it as butanol. Here we have a ketone and an aldehyde, but according to the preferences, first is aldehyde and then next is ketone. So this is the principal functional group, and this functional group we have to write it as a prefix. So the prefix for the ketone is oxo. It is on the 3rd carbon, so we write it as 3-oxo, and we start numbering this way: 1, 2, 3, 4, 5, 6. Cyclohexane. This is cyclohexane, and the suffix we write it as carbaldehyde because we are not counting this carbon, so we write it as carbaldehyde. This becomes 3-oxo-cyclohexane carbaldehyde. So identify the parent chain. So this is the parent chain. Our aldehyde group should get the lower value. So this is 1. So our parent chain starts from this way. Here we have a substituted substituent. So how do we name this? So this is, we have 5, so it is pentanol, and we have methyl group here. So on the 2nd carbon we have, for the second carbon we have a substituent. For this substituent we have, on the 1st prime we have 1 more substituent. So this is substituted substituent. So for this we write it as, on the 2nd carbon we have, for the 1st carbon, that is for 1 prime, we have a methyl group. So this becomes 1 prime methyl ethyl 4 methyl pentanol. This is how we write 5 carbon chain. So it is pentan, and it is we have an aldehyde group, so we write the suffix as al, and here we have substituted substituent. So for this 2, on the 1st carbon, that is we have 1 more methyl group, so we mention it as 1 prime in brackets, and then 4 methyl pentanol. Look at this. Here we have 3 aldehyde groups, and this is an unbranched hydrocarbon. So for an unbranched hydrocarbon, if you have more than 2, like if you have the same groups more than 2, and if they are directly attached to the hydrocarbon, if they are directly attached to this chain, then they are written this way, that is propane 1,3, 1,2, 3. I have written it here 1,3, 5. This is wrong. It is 1,2, 3 tricarbaldehyde. We have tried it as propane. We have 3 carbons, so it is propane, and 1,3, 1,2, 3 tricarbaldehyde. We have 3 aldehyde groups, so it is tricarbaldehyde. Consider this example. Here we have a branched chain. So we write it as usual. We start numbering this way: 1, 2, 3, 4, 5. And this is treated as a substituent, so this becomes 3,4-methyl methyl pentane 1,5 dial. Here we have two principal functional groups, so in the parent chain, so we write it as pentane. We do not cancel E, we write it as pentane 1,5 dial. Here it is a branched chain, so we do not follow this rule. This rule is only for the unbranched chains, where the functional groups, if you have more than 2 functional groups, same functional groups are attached to the chain, directly attached to the chain, then this is how we follow. We do not count from this way, that is, we do not count from this carbon and go this way. Instead, we write like this: 1, 2, 3. So it becomes propane 1,2, 3 tricarbaldehyde. So this is also a branched chain. Here we have same functional groups, that is same functional group, that is aldehydes. Aldehyde group we have, but here this is a branched chain. So we have to number as usual, that is 1, 2, 3, 4, 5, 6. Then this becomes 3,4-methyl methyl, because this is treated as substituent, so you have to write this up as a prefix. So the prefix for the aldehyde is 4-methyl, so it becomes 3,4-methyl hexane 1,6 dial. So this is how you write the name of the aldehydes. If you have more than 2 same functional groups directly attached to the unbranched hydrocarbon, then we do not count those the carbons in the functional group. Instead, we count the chain. Here we count the chain, this chain, that is 3, and write the name, that is propane 1,2, 3 tricarbaldehyde. For more videos on nomenclature of organic compounds, follow me on Unacademy. Thank you.